In the last class, we are studying the oxidation of alkenes. That alkenes, they can be oxidized by acidified potassium manganate solution by acidified KMnO4 solution. It is a strong oxidizing agent. Okay, so we have studied about cold dilute acidified KMnO4 solution. If we add cold diluted acidified KMnO4 solution to an alkene, formation of diol will happen. Okay, the carbon-carbon double bond will break here. It will convert it into a single bond, and we add OH and OH here. This is in the case of when we have cold dilute acidified manganate solution. But if we have hot concentrated manganate solution, hot concentrated KMnO4, so these are your harsher conditions. Here the carbon-carbon double bond is broken completely. Okay, so this OH group, it is further oxidized to ketone, aldehyde, carboxylic acid or carbon dioxide gas like this. In the first reaction, we have C double bond C and we have two hydrogens which are attached. So it is oxidized to CO, carbon dioxide. If you have one alkyl group, it is oxidized to aldehyde group, RCHO. If you have two alkyl groups, this has happened when there is one alkyl group, then you have a formation of aldehyde. Further oxidation means it will add oxygen to this bond also. CH bond also, it will add oxygen here, so it becomes carboxylic acid. If you have two alkyl groups here, then the formation of ketone will happen. So this is the procedure of oxidation of alkenes with hot concentrated manganate solution. If you have both hydrogens, it is converted into carbon dioxide. So write it down. Both alkyl groups, it is converted into ketone. One alkyl group, it is converted into aldehyde, and both hydrogen, it is converted into ketone. What if we add this alkene into an hot concentrated KMnO4 solution?
I'm done.
When you heat 2-methyl-propane, draw the structure of 2-methyl-propane, and when you heat it with hot concentrated acidified KMnO4 solution, so what will be your product? Draw the structure 2-methyl-propane. That means there are 3 carbon atoms. At second position you have methyl group, and at first position you are having a double bond. It is CH3 and it is CH. This is my 2-methyl-propane. So when you heat it with hot concentrated acidified KMnO4, that means which reaction will occur? Oxidation. Oxidation will occur. Okay. Now look at the double bond. This is my double bond. At this carbon, you have both the alkyl groups. So the formation of ketone will happen. So you break it here like this, and you just have to add double bond O here. So it becomes CH3C double bond O CH3, which is your propanol, ketone. Okay. Plus we have CO2 plus H2. Okay, because here also oxygen will add, it will become HCHO. Then what happens? CO2 will liberate out and H2O will liberate out. But your product will be propanol. So there are 2 alkyl groups, and if there are 2 alkyl groups, the product is propanol. You cannot further oxidize it. If there is only one alkyl group, then you can further oxidize it. Because the product is aldehyde, you can further oxidize it to carboxylic acid. This oxygen is your nascent oxygen, as I told you in the previous class also. It helps in oxidation. Where does it come from? It comes from your KMnO. It is an oxidizing agent. The oxidations under harsh conditions using a hot concentrated solution of potassium manganate in 3 reactions. First is that if it is bonded to 2 hydrogen atoms, we get oxidation to a CO2 molecule. If it is bonded to 1 hydrogen atom and 1 alkyl group, we get oxidation to COH carboxylic acid. First we have aldehyde group, then they further oxidize to carboxylic acid. If a carbon atom is bonded to two alkyl groups, we get oxidation to ketonic. This is my two alkyl group R1 and R2. So here cleavage happens, and here we have O and O. We have double bond O here and double bond O here. So this is a summary of the oxidation reaction using hot concentrated KMnO4 solution.
I'm done. I'm done.
This is your homework question for today. Draw the displayed. This is your homework question. Draw the displayed formula of the organic compound formed when propene is oxidized by a cold solution of acidified potassium manganate. Name the compound. Draw the displayed formula of organic product formed when butene is oxidized by a cold, that means oxidation. And here also it is heated with concentrated acidified potassium manganate solution. Draw displayed formula and name them, and write a balanced chemical equation for this reaction using nascent oxygen to show the oxygen atoms in form. If oxidation is clear to you, then you can answer these questions. Please write it down.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
I'm done.
Study about the addition polymerization. So what is a polymer? Polymer is a long chain molecule. So why we are studying the polymerization? Because it is a part of alkene, and alkene is a part of hydrocarbon. Okay. So polymers are formed from alkene. So polymer is a long chain molecule which is made up of many repeating units, and the small reactive molecules which react together to make a polymer are called monomers. Okay. Poly means many and mer means units. So many units combined together to form okay. I mean single units combined together to form many units. Monomers combined together to form polymer. Up to 10,000 ethene monomers can bond together to form the polymer chains of polyethene. Okay, polyethene, which we use to make carrier bags. How it is made? It is made by the polymerization reaction of ethene. So this is ethene. So N molecules of ethene, they polymerize, and we have C2H4 polyethene. So what you have to do here only, you just have to remove this double bond. You just have to convert your double bond into a single bond, put a bracket here, and you just have to write N. N means it is very large, it is up to 10,000. So the section of polymer which is shown in the bracket, it is the repeat unit of the polymer. That means after this you have another this unit. Then you have N times, means 10,000 times this unit is repeating. So it is your this is the process of polymerization. Clear? Up to N times this unit is repeating. So this is your addition polymerization. Write it down.
I'm done.
Called addition polymerization. As in other addition reactions of the alkenes, here also pi bond is breaking in C double bond C bond and the monomers link together. Other alkenes and substituted alkenes also polymerize. So this is the example of only ethene, but other alkenes and substituted alkenes, they also polymerize to make polymers. They have different properties. For example, polypropene, polychloroethene. So we can show the polymerization reaction of propene. It is also same NC3H6. You just have to remove the this N, and you have to put this N here, and you have to make a brackets. Brackets means this is a repeating unit. Or you can use the structural formula. The double bond is, you have to convert this pi bond into a sigma bond, and you have to apply brackets to show the repeating units, and you have to write N, the value of N here. N can be up to 10,000.
I'm done.
Okay, so this shows the regular arrangement of your methyl groups along the polypropylene polymer chain. That means that you are making like this N. So this is your repeating unit. Again, this unit is repeating. Again, this unit is repeating. Then again, this unit is repeating. So it is just showing that how the units are repeating up to many.
I'm done.
This would be which one of the following statement is correct? What should be the correct answer of this question? Just read the question and then tell me the answer. Which one of the following statements is correct? First is polypropylene and polyethylene will both decolorize bromine water. So I already told you which substances decolorize bromine. Polyethylene is a saturated hydrocarbon. You know the difference between saturated and unsaturated hydrocarbon, right? Polypropylene will melt at a lower temperature than propene. The polymerization of ethene is an example of an electrophilic substitution reaction. So only one statement is correct in this question. Which statement is it?
Is it B?
Yes, B is the correct statement. Polyethylene is a saturated hydrocarbon because we have just studied that polyethylene, that means all the double bonds are converted into single bonds and single bonds are saturated hydrocarbons. First one is incorrect because only unsaturated hydrocarbons will decolorize bromine water, but polypropylene and polyethylene are saturated hydrocarbons, so this is incorrect. B1 is correct. C, polypropylene will melt at a lower temperature than propene. So this is also incorrect statement. Why? Because these have higher melting point. Okay, polymers have higher melting point. Polymers have higher melting point than their monomer. Now the fourth statement is polymerization of ethene is an example of electrophilic substitution reaction. No, there is no electrophile in this reaction. So the D part is also incorrect. It is an example of addition polymerization. Addition reaction. Okay, because in this reaction monomers add to one another in such a way that the polymer contain all the atoms of the monomer unit. You want to write this question or should I change?
You can change.
We can also use substituted alkenes such as we have studied polymerization in polyethylene, polypropylene, right? But if I use substituted alkenes such as chloroethene, where one hydrogen is replaced by chlorine, then what is my polymer product? Polymer product is polychloroethene. You just have to write poly here in the prefix and the name is same. And what you have to do in the formula, you just have to convert double bond into a single bond. You have to put brackets and the L. So this section of the polymer chain is called the repeat unit of the polychloroethene. So you have to remember that the section of polymer chain shown inside the square brackets by structural or displayed formula, it is called as repeat unit. What is repeat unit? Section of polymer chain which is shown inside the square brackets. Addition polymerization, it is characterized by, that means in addition polymerization you should have monomer which are unsaturated and the polymer which is the only product of the reaction. That's why it is addition polymerization. In addition polymerization, only one product will be the product in this reaction.
I'm done.
Okay. So that's all for today's class. In the next class, we are going to learn about the disposal of polyalkenes or disposal of plastics, and hopefully we'll complete the chapter tomorrow, and then we'll practice some questions of this chapter.